Hello everybody, we're going to start the next section, which is proving that a quadrilateral is a parallelogram. So these are going to be a lot of different theorems and proofs in this section, and a lot of the proofs are the same ones that we did in the last section, just the opposite. So you can decide whether a quadrilateral, which is four sides, is a parallelogram if its sides, its angles, and diagonals have certain properties. In the last lesson, like I said, we learned about all the properties of a parallelogram. Now we'll begin going through the converses of these properties. So the first one, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So if I have two opposite sides that are congruent, then it is a parallelogram. And before, we had if it's a parallelogram, then it's the opposite sides are congruent. Now it's just the converse of it. So most of the theorems we have today are just going to be the ones we had before, just the opposite. All right, we're going to go through the next two theorems, which have to do with the angles being supplementary and the angles being opposite. Okay, so the first one is the converse of 6,4, which talked about the supplementary angles. So this one says, if an angle of a quadrilateral is supplementary, meaning add up to 180 degrees, to both of its consecutive angles, meaning that the angles that are next to it, then the quadrilateral is a parallelogram. So angle A and angle B add up to 180 degrees, angle A and angle D add up to 180 degrees, then it's a parallelogram. So this is what it means by being supplementary and 180 degrees, and by being consecutive next to angles. You could have chosen any angles you wanted, but as long as you prove it for one angle and another, one angle and another. So one angle has to be the same. Next question, next theorem. If both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. I want to go away. So this one, I have angle A is congruent to angle C, angle B is congruent to angle D, then it's a parallelogram. So these are all things that we had in the previous lesson, just going through and doing the opposite with it. Alright, now we're going to be given a problem where we're going to have to find lengths of sides and the lengths of angles of different parallelograms. Okay, so this question is asking us, for what values of y must PQRS be a parallelogram? Now, for it to be a parallelogram, we need to have the opposite sides being congruent. So we're going to need to first solve for x in this equation. And then from x we can get to y. So we could set up 3x minus 5 is equal to 2x plus 1. Then x minus 5 is equal to 1. Then x equals 6. Then from there, since we know that with the value of x, we can plug it back into our other equation, y equals x plus 2, to solve for y, and get that y equals 6 plus 2, so y is equal to 8. So therefore, PQRS to be a parallelogram, the value y must be equal to 8. So simply setting up the opposite sides, being the same, and solving for the different variables. Now I'm going to give you a question where you're doing the same thing, except this time it's angles. So this is y plus 10, 3y minus 2, 4x plus 13, and 12x plus 7. And I'll have a question now. Okay, this next one theorem is about the diagonals. So if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So if AE is congruent to CE and BE is congruent to DE, then we have a parallelogram. Basically the opposite of what we had before. There's a proof on this, but we're not going to go through it. I want to make you guys do it during class time. Ha 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 ha. And the last proof we have for today is kind of combining a bunch of ideas. If one pair of opposite sides of a quadrilateral is both congruent and parallel, then the quadrilateral is a parallelogram. So, if BC and DA are congruent and BC and DA are parallel, then it's a parallelogram. So basically this theorem says if you have one side that's parallel and congruent, then both sides are going to be parallel and congruent. That's basically what this theorem here is saying. Alright, we're going to go through one example problem. I'm going to give you a question to do, and then we're going to sum it all up in the 6 different ways you can prove quadrilaterals as parallelograms. Okay, for these 2 questions we're asked to see if we have enough information if we can show that these 2 quadrilaterals are parallelograms. So the first one says that AB and CD are both equal to 5, and A is 50 degrees, D is 130 degrees. Can we show that this is a parallelogram? Yes or no? Well, we can, because first off, we have AB and first off we have angle A plus angle D are supplementary, so that makes AB and CD parallel, but they're also congruent because they're both equal to the same one. So this parallelogram would be a quadrilateral because of the theorem 612. If the opposite sides are parallel and congruent, then it's a parallelogram. The next one, we're asked to see if this one here is a parallelogram. We're given that HI is congruent to HK, JI is congruent to JK. This one, we cannot show it is a parallelogram because the opposite sides are not congruent. This side is not the same as HK is not the same as JI, HI is not the same as KJ, so we cannot show that these are congruent. Alright, now we're going to have 2 questions. First one, prove this one is congruent, and then I'll give you time, and then you'll have to do this one. So first, proving, can you show this one as a parallelogram? Yes or no, and explain. Okay, now, can you show that this one is a parallelogram? Yes or no, and explain. Okay, so here's a list of everything that you can do to prove that a quadrilateral is a parallelogram. So you could either prove that both pairs of opposite sides are parallel, like this picture shows. And the reason for that would be definition of parallelogram. Prove that both pairs of opposite sides are congruent. Prove that an angle is supplementary to both of its consecutive angles. So this is 105, 75, and 75. Prove that both pairs of opposite angles are congruent. Opposite angles being congruent. This is theorem 610. Prove that diagonals bisect each other. Theorem 611. And then prove that one pair of opposite sides is congruent and also parallel. Alright, that's going to be it for today. Again, I'll leave a question and we'll go over any questions you guys have about this video in class, and then there will be a quiz at the end of the class.